Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome into the program. I hope that you are doing well. You're having a fantastic week. And everyone, hey, we got a great show for you. Because on the show today, Ralph, of course, joins us for 4 great stories, and everything from those who are experiencing these winter storms and these winter chills. Story number 1 might be for you with some clothing that can get extra toasty. Don't even have to throw it in the oven. It just works. Technology, it's so fun. Anyways, and then our 4th story that we are going to talk about gives a whole new meaning to bug eyes. So, ladies and gentlemen, I apologize for any technical hiccups that we have. Well, this might be a problem, but ladies and gentlemen, we'll figure it out. So let's go ahead, bring Ralph on, and everyone, hey, let's go ahead and get started with today's show. So today on the program, we of course have Ralph Bond. He is our science and tech trends correspondent. Really enjoy having him on every single Friday to talk really anything that catches his fancy, and these are stories that generally fly under the radar. They're stories that are, have a positive twist on them that leave you thinking, hey, this whole technology, this whole computer thing, it might not be so bad. It's gonna be okay. So let's go ahead, bring Ralph on, and just have fun with it. So Ralph, welcome back onto Computer America. How you been?
Okay, it's great to be back. And if you're new to the show, and you're listening to us as a podcast, I can't stress this enough. Please come out to computeramerica.com. Get the show notes, what we call the show notes for today's show. It has the title of the articles, it has links, it has additional information I add to the articles. And again, what we're going to do is just give highlights. But before I say that, let's set the stage. What Ben and I do each Friday is look at stories covering a whole range of technology, artificial intelligence, robotics, agricultural technology, medical technology, physics, space news, aviation technology, all across the board. But the most important thing of all is this is a chance for you to end your work week with uplifting and positive news. We're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And you picked 4 amazing stories. And ladies and gentlemen, if you want to find out more, as you said, computeramerica.com. By the time that you hear this, you can follow along or come out after you hear this and chase down the links. Ralph does an amazing job of the highlights, but there's always more to find in the articles themselves. And sometimes, hey, even the papers. So, cutting edge indeed. So Ralph, I believe with that, let's go ahead and get started with story number 1.
Yeah, story number 1 comes from livescience.com. The headline, and boy, this time of year, this really caught my attention. Up here in Oregon, we finally got some snow, which was very exciting for us in the Portland area. But anyway, the headline is, new fabric can heat up more than 50 degrees to keep people warm in ultra-cold weather. Okay, well, all right. We've seen a lot of products that have little battery-powered heaters that go into your vest or shirt or whatever, but this is something special.
So, by the way, I like that you said Oregon finally got some snow. I didn't watch much news, but the little snippet of news of the evening news that I did catch last night, it was like Oregon got snow, and they were talking about like 100-car pileup. They were talking about cars on fire, just chaos reigning in Oregon over the snow. So, it's all how you see it,
That is so true. And to clarify, it's in the Portland area. So the Portland area doesn't get snow very often at all. So we're all weather weenies. My son-in-law, who's from Wisconsin, just laughs at us. He thinks, you guys, this isn't weather. This isn't winter. What are you talking about? But we just can't handle it because we're not used to it at all in this part of Oregon. Now, in the Central and Cascades, of course, they get a lot of snow. They're very used to it. But in our area, it's very, rare, relatively speaking. So anyway, with that said, the first story definitely relates to our situation and many people in the Northern Hemisphere going through cold winter right now. So let's dive into this. It says here, scientists at the University of Waterloo in Canada have invented a fabric that converts light into heat and can raise temperatures by more than 54 degrees Fahrenheit and 30 degrees Celsius for the rest of the world after just 10 minutes in the sun. What? In the sun? Just sun exposure? Huh. The new material could be used in clothing designed for very cold temperatures. And here's how it works. Specialized nanoparticles that absorb sunlight and convert it to heat are embedded within the new material. At the same time, temperature-responsive dyes incorporated into the fabric's fibers change color, allowing users to visually monitor temperature fluctuations. So let's stop for a second here. Exposure to the sun causes the fabric to warm up, and as it warms up, the color of the fabric changes so you can see it. Sounds like fun to me.
It's very, I think the article broke down a little bit more than the paper would. And again, the article that Ralph linked has the paper included that you could read more. It's not just absorbs sunlight, warms up. There's more to it, but basically that's how it works.
Yeah. And I'm glad you brought the point up. In the show notes again, folks, we add things. There's links to the scientific papers, which are very deep and very geeky, and you can get more. And I want to stress again, what we're going to do here today with these 4 articles is just give you the highlights, just give you the key points. And the idea is to tease your interest. You come get the show notes and dive deeper if you want to. But going on with the highlights here, for years, scientists have designed wearable fabric heaters to help maintain a comfortable body temperature in cold environments. Such fabrics could be used in mountain rescue equipment or even pet clothing, but existing designs typically rely on expensive components such as metal nanomaterials or cumbersome battery-powered heating elements. And lately when we walk the dog, I'm fine. Everything's great except my hands. So I was on Amazon.com and I was looking at heated gloves. The doggone things are well over $100, and you have these big kind of like power bricks that have to go into the gloves, and forget it. That's been the normal thing for that kind of stuff, and this is why this story also caught my attention. Going on, to get around these problems, the researchers at the University of Waterloo in Canada looked to photothermal polymers, which are plastic-like materials that convert light into heat. And I insert a little bit of side notes because I thought, well, wait a minute, photothermal polymers, I want to learn more about that. So photothermal refers to the conversion of light, usually from sunlight, into heat. And this concept is utilized in a variety of technologies and scientific applications. And you can dive into the show notes and learn more about this, but those applications include photothermal therapy in medicine and photothermal solar panels. You've seen sometimes those panels on a roof. They're not for electricity, but they're to heat up your water. So that's what they're talking about with photothermal.
Yeah, it's becoming more and more popular for kind of taking your water heater off your energy bill, and just at least that part of your house, making it a bit more green and efficient. But hey, turning it into clothing, that's a step beyond what I've heard.
Yes, that's right. So the nanoparticles of the 2 polymers in question, one being polyaniline and polydopamine, are embedded within a matrix of thermoplastic polyurethane fibers. And note, thermoplastic polyurethane fibers are a material widely used to produce waterproof clothing and sportswear. So they're taking some ingredients that are pretty commonly known, but injecting scientific nuances, as it were, to make this new fabric. The team also incorporated various temperature-responsive thermochromatic dyes into the mix during the spinning process, producing a series of fibers that changed color as the temperature of the material increased. And get this, you'll love this, Ben. These newly spun fibers were readily woven into a fabric, and to test the new fabric, the team knitted a tiny sweater for a teddy bear.
Of course.
Okay. The red sweater reached an impressive 128.3 degrees Fahrenheit, or 53.5 degrees Celsius for the rest of the world, after just 10 minutes of sun exposure. What? 128.3. It must have been some pretty intense sunshine. As the temperature climbed, the red dye molecules in the fabric of the sweater changed chemical structure, causing them to turn white. Okay.
I think we have a
fabric
photo.
has a soft and elastic texture, which allows the material to stretch by as much as 5 times its original size and retain its color and temperature-changing properties even after 25 washes, according to the study. Pretty amazing stuff.
So for anyone out there watching the video portion, I think we have a photo of the teddy bear after it was left in the sun for 15 minutes. And yeah, it's very warm. 128 degrees, that might be a little bit of a problem. I wonder if if that's going to be like, maybe less fibers to make it like to kind of cap the heat that it can do. But
yes,
whew, that's toasty.
Well, and to wrap things up on this first story, one of the things we often do is what we call a reality check. And the article itself gets into this. And this reminds me, friends, a lot of what we're going to talk about week after week is early research. You're not going to go to Costco or Walmart or Target and pick up a sweater made with this stuff next week. No, it could be years from now. So this reality check at the end is the team is working to prepare the material for commercial manufacturing, but they still have to do further testing before it can gain widespread use. So there it is for everybody suffering the cold right now. There is hope for your clothing to help you out, so long as you have good sun exposure.
For sure. It's, and that could also be a limitation, but, for survival situations or things like that, hey, this could be very, very handy for so many things. Story number 1, great, uplifting, love it. Story number 2, we're going to move on to the world of recycling. And, Ralph, this is a trend that you definitely have been following where, recycling isn't just an end-all be-all process, because what we found out through years of doing Computer America, talking with some of these organizations, it's like, as far as like, it should be as easy for the consumer to put something in the correct. Okay. Ignore that pause. It should be easy for consumers to just put something in the correct bin, and that would be it. That's what you would wish. But in reality, the process of recycling is ever changing. It can get better, more efficient. It's a very it's something that needs to get better over time, and it will get better over time. And story number 2 is kind of leading to that because, these breakthroughs, while they are, as Ralph said, maybe years in the making and, maybe a couple years out from even implementing, they're still important to recycle. We don't have recycling figured out, but hey, maybe stories like number 2, can give us a little bit of hope that we will be able to get recycling under control. So, Ralph.
Yeah. Story number 2 comes from Yahoo Tech, their Today in Tech section. And the headline here, this is what caught my eye. MIT, of course, good old Massachusetts Institute of Technology. MIT engineers develop breakthrough technology that could change the way we process recycled aluminum. And in this case, in the show notes, I have not only the link to the Yahoo Tech article, but I have a link to another article in techexplorist.com, which is a really good article, and also their research paper. And so this is important because, gosh almighty, aluminum cans, pop cans, and so forth are a big, big part of our recycling world. But here we go with this story. Researchers at the Massachusetts Institute of Technology recently developed a new method of recycling aluminum that could make the process more efficient while reducing hazardous waste. It's kind of one of these win-win stories. And the method involves a newly created ceramic nanofiltration membrane that can selectively capture aluminum ions from industrial waste sources, most prominently being recycled aluminum cans. Now, the author says, while that might sound a bit technical, the important takeaway is that this new development can recycle more aluminum while reducing polluting byproducts. Huh. Pretty cool stuff. And Ben, you can just imagine how many billions of tons of aluminum cans are out there. Some, unfortunately, going into landfills, but hopefully mostly getting recycled.
Yeah, it's and then they're even talking here that, and that'll probably be the next point, but even the ones that do get recycled don't get recycled perfectly. Like it's not a one-to-one capture. Put one aluminum can in, get exactly one out. So yeah, it could be better. So as to the next point.
No, you raise a really good point, and that is the key thing. It's great when I go to Costco with my bags and bags of my bubble water cans and get the little bit of money through the recycling machine, which is a blast, by the way. But that ultimately is not going to necessarily result in retaining or regaining or retrieving all of the aluminum. That's the key of this story, so you're right on target. So it goes on to say here, one of the researchers noted, quote, "We were able to capture 99.5% of the aluminum ions. And even after sitting in highly acidic solutions for weeks, the membrane maintained its high performance." This is this nanoceramic membrane they created to capture the aluminum ions. And this is a huge advantage, as aluminum waste is typically acidic, which can degrade less durable materials. And then another team member noted, to wrap things up here, we're not just preventing waste. This membrane technology also enables a circular economy for aluminum. And I would say it amplifies it because we already have that, but enables I'll say, better circular economy for aluminum, which could reduce the need for new mining and help mitigate some of the industry's environmental footprint. So there's so much more details, Ben, in their research paper. The illustration that's in the show notes from the article shows the cycle they're talking about and more details. So there's a great deal of geeky technology underpinning this that we're just glancing over very quickly. So come out to the show notes and dig deeper if you so desire.
For sure. Yeah. And, these resources, they're not infinite. And hey, if we can get access to them, if we can, utilize them better, that is, hey, that's part of the 3 R's: reduce, reuse, recycle. And so, hey, reusing is a huge part of that whole thing. So very cool. And, hopefully we see it soon. Story number 2, story number 3. This one has to do, a little bit of AI. It's getting into everything, and looks like it's even getting into the research field. Now, luckily, we haven't completely handed over research to computers, but we're finding that researchers are more and more turning to computers to help them make breakthroughs that, Ralph, and over the last 10, 15 years, how many times have we heard, computer simulation finds new way to do X? Is it like layering photovoltaic cells? Is it, reorienting something, redesigning CPUs and things like that? Like, we've seen a lot of stories that computers don't think like humans all the time. And sometimes that is, that's a breakthrough in itself. So I think we get something a little bit like that here in story number 3.
Yes, indeed. And this comes from technologynetworks.com. And it's actually just basically a reprint of a news press release from the University of Toronto. Oh, this is our second Canadian thing this week. And the headline is "Machine Learning Designs Materials as Strong as Steel and as Light as Foam." And I just remember the bit about how spider webs, the threads of a spider web, in terms of comparing it to steel, if you were to make a thread of steel as small and delicate as a spider web, the spider web is infinitely stronger than the steel.
Yep.
And so just kind of realized that. Again, the headline, "Machine Learning Designs Materials as Strong as Steel and as Light as Foam." Oh my gosh, the implications of this are profound. Anyway, there's several links in the show notes here for you to learn more if you want to. And warning, this is a very geeky story that involves multiple international contributors. So a little bit of warning about the geekiness of this. But let's get into it. Researchers at the University of Toronto's Faculty of Applied Science and Engineering have used machine learning, there's your artificial intelligence, to design nano-architected materials that have the strength of carbon steel, but the lightness of styrofoam. What? How does that happen?
It sounds like a very strange cross section of properties, because when you think strong, you think heavy, and when you think light, you think weak. And yeah, they somehow managed to combine the two.
Exactly. So, reminder, by the way, nano typically refers to things that are extremely small or related to the nanometer scale, which is 1/1000th with a B, 1/1000th of a meter. So, in a new paper published in Advanced Materials, the research team describes how they made nanomaterials with properties that offer a conflicting combination of exceptional strength, lightweight, and customizability. Wow, this approach could benefit a wide range of industries from automotive to aerospace. Just think about automotive. Think about your electronic vehicles. What if the body parts of a car could be as strong as steel, but weigh the weight of styrofoam? Now your battery and your everything else can go farther, longer distances. This combined with other technologies could be a revolution for the EV auto industry, right?
It's already done that in our lifetime, Ralph, with carbon fiber.
Yes, right.
If you think about race cars, boats, even just everyday consumer cars, like carbon fiber has replaced so much in these high performance things. And I guess it would be that to another degree, which is the material they're talking about. So.
Exactly right. And the lead author of the research paper noted, quote, nano-architected materials combine high-performance shapes, keep that in mind, high-performance shapes, like making a bridge out of triangles at nanoscale sizes, which takes advantage of the smaller is stronger effect to achieve some of the highest strength to weight and stiffness to weight ratios, that's important, stiffness to weight ratios, of any material. Now, here's the problem the team faced, according to one of the researchers. However, the standard lattice shapes and geometries used tend to have sharp intersections and corners, which leads to the problem of stress concentrations. This results in early local failure and breakage of the materials, limiting their overall potential. So they're saying, to date, the little nano shapes and so forth used to try to create these materials had these problems of sharp edges and so forth. It just wasn't working out that well. So the team realized that this would be a perfect problem for machine learning to tackle. Of course, we're talking about artificial intelligence. And everywhere, every day, they're applying artificial intelligence to solve problems that for humans would take us years and years.
Yeah. So for everyone out there, as we kind of listen to the rest of the story, if you want to look on the screen, and for everyone who can just listen, like the shapes that it comes up with, it may look like a doodle, on a piece of paper, like a geometric doodle you may do, but these are very, kind of precise geometric shapes that they're kind of doing. And I can't really move it up. I wish I could zoom it up. But anyways, Ralph, I think they nailed the sharp corners, because man, these are so intricate. But obviously you could tell stable.
Oh, yeah. And again, friends, if you're listening to us as a podcast, please come out to computeramerica.com, get the show notes, check out the paper. He's pulling up images probably from the research papers, I recall. And it is quite intriguing. So this is going on with the details of this. And again, it's very geeky. You can learn more if you come out and get the show notes. But going on here, it says nano-architected materials are made of tiny building blocks, which is what Ben is showing on the screen here, or repeating units measuring a few hundred nanometers in size. And get this, it would take more than 100 of these little shapes, more than 100 of them patterned in a row, to reach the thickness of a human hair. Whoa. These building blocks, which in this case are composed of carbon, are arranged in complex 3D structures called nanolattices. And that's exactly what Ben has up on the screen right now. Fascinating. To design their improved materials, the University of Toronto team worked with two scientists at the Korea Advanced Institute of Science and Technology in South Korea. This is the international part of the story I mentioned at the beginning. The Korean team employed an algorithm that learned from simulated geometries to predict the best possible geometries for enhancing stress distribution and improving the strength to weight ratio of nano-architected designs. I know that's a brain mouthful, but it's so important. And then here, this gets even geekier. Next, a 2-photon polymerization 3D printer, housed in the Center for Research and Application in Fluidic Technologies in Toronto, was used to create prototypes for experimental validation. This additive manufacturing technology enables 3D printing at the micro and nano scale, creating optimized carbon nano lattices. And in the show notes, if you want to understand what a 2-photon polymerization 3D printer is all about, I have data inserted in there that I picked up from a Copilot AI query, and you can dive into that. There's a whole lot of detail about what that is if you're interested. And then going on here, one of the lead researchers noted, quote, "This is the first time machine learning has been applied to optimize nano-architected materials. And we were shocked by the improvements. It didn't just replicate successful geometries from the training data, that means the large language model in AI, it learned from what changes to the shapes worked and what didn't, enabling it to predict entirely new lattice geometries." Again, very geeky, very deep. Check it out if you want to learn more, but another hit for AI.
Yeah. It seems like they created something that I can see why they said aerospace, because you would need that kind of budget to make these things to use any kind of suitable application. But, if you could do this, replicate it enough and over again in this precise pattern, this sounds like, this kind of thing would be stronger than anything else. And when you just need the best, money be darned, just throw the money into a trash can and light it on fire. This sounds like it's already out competing a lot of other material out there on the market. So no, it's really incredible. And, I don't claim to understand anything at like the top part of this picture, but the fun shapes at the bottom look fun. So there you go. Ladies and gentlemen, hey, you definitely have to come out to the show notes and check out for yourself. Okay, so I said at the beginning, story number 4 gives a new meaning to bug eyes. And story number 4, it's a way to, hey, maybe restore vision to those who, who have had problems. So Ralph always dedicates story number 4 for those who are completely new to this whole thing. Story number 4 to medical technology. This can cover anything from breakthrough cures to new developments in treatments. You can do prosthesis. You can do so many different ways technology touches science in this manner and helps people live better lives. Story number 4, no different. And let's go ahead and talk about these new smart glasses.
Yes, and if you want to end the show on an uplifting note, although we're going to have honorable mentions in a little bit here, this one really does the trick. It comes from wonderfulengineering.com, and believe me, this is an example of wonderful engineering. The headline, absolutely irresistible, new smart glasses use insect vision technology to restore full 3D visual experience, offering treatment of macular degeneration. Oh my gosh, if you know what that is, you realize, wait a minute, this is very important. And there's a great video, by the way, on the opening page of the company we're going to be talking about that's come up with this. And by the way, this is related to the Consumer Electronics Show that recently happened. But let's dive into this. This is really, really a great uplifting story. So Solid Vision, smart glasses developed by Solid Corp and unveiled at the Consumer Electronics Show very recently, are set to revolutionize the treatment of macular degeneration, a leading cause of blindness. This innovative design is inspired by a fly's eye, combining virtual reality and augmented reality technologies. Whoa, okay. Wow, so amazing. Macular degeneration, try that again. Macular degeneration affects nearly 19.8 million people over age 40 in the United States alone, blurring central vision due to damage to the macula. And again, if you go out to the company's website, they have a kind of recurring little video that goes through this whole process of what macular degeneration looks like to people who suffer from this. It's terrible. Solid vision addresses this by projecting multiple images onto healthy areas of the retina. So in macular degeneration, folks, when you look at something, the room or landscape, there's sort of a dark, blackish cloud in the center of your vision. That's what we're talking about. So again, what these guys are doing with these specialized glasses is projecting images onto the healthy areas of the retina. The healthy areas of the retina are around that center core of darkness. So that's what's going on. And Ben, this blows my mind. Using lenses modeled after a fly's eye, the glasses direct parallel rays of light to the retina's undamaged peripheral edges, creating a complete visual image. And this approach leverages the brain's ability to process these inputs into a cohesive picture. Ben, amazing stuff.
Yeah, I know from my very basic science classes that the image that goes into your eye is actually flipped, and then your brain unflips it and does all the kind of manipulation. That, Ralph, it seems like they're like maybe the first time that you put these on, you may see 100 of the same image. It'd be very confusing, but eventually your brain learns, hey, this is one, as they said, one cohesive image. This is just one picture. So it might take some, adapting to it, but yeah, it's really incredible. And, that they're, I guess, like they said, just trying to replicate around, like they're not trying to cure, because so many of our stories, like how do we fix the human body, they're just trying to go around it, and the body, and the brain's natural processes are going to figure it out. They're just giving more information to the healthy spots. Very cool idea.
Yeah, I was just thinking as we were speaking, you can think of it as a visual aid prosthetic of sorts, but for your vision, right?
For sure.
So going on with the story, the glasses feature advanced 3D technology and computer vision artificial intelligence to enhance areas of the visual field typically lost to patients. And this just gets more and more and more interesting. Folks, please come out and get the show notes. Look at these images. Look at the video that the company has on their website. You'll love it. Equipped with onward and inward facing cameras, the glasses capture what the user sees while tracking their gaze, sending 100 views to the displays behind the lenses. Each display contains 49 lenses, with future versions expected to feature triple this number. Wow. This design mimics the brain's natural visual processing, enabling stereopsis, the depth perception, and creating an in-focus 3D visual experience. That goes to your point about how much training is involved when you get these glasses, you have this problem. Does it take a lot of training and so forth? The implication is probably not. And then to wrap things up on this story, clinical trials at New York's Lighthouse Guild demonstrated the effectiveness of solid vision glasses, with 50% of the 30 participants showing measurable improvements in reading abilities. Now, is it perfect? No, 50%, but still 50%. And if you get an improvement, I'd be very welcome to that if I had this disorder. Testimonies from trial participants highlight the glasses' transformative impact, offering clearer vision and enhanced quality of life for those with retinal diseases. So now, reality check. The technology is poised for commercial release this year. So unlike many of our stories where it may be 5-10 years out before this gets to the real world, this company is hoping to get this out in the field this year, pending additional patient testing.
Yep.
So that ought to leave you on a happy note for Friday. Uplifting, especially for people who suffer from macular degeneration, which is a nasty disorder.
For sure. And, and like they said, affecting so many people in the world. And just poking around their website real quick, obviously, like Ralph says, there's always more to find out. Looks like you would essentially get these through your healthcare or, through your eye care provider. So as a patient, you can go in and be like, hey, I've heard about these glasses. I want to check these out. And then your eye care professional would work with you to get them. So it's not like, pull them off the shelf and be like, oh, I can see amazingly now. No, but still, even as, kind of like a prosthesis, it still may be an option later this year. So very, very cool. Something we may something we may see, no pun intended, sooner rather than later. So, Ralph, that was story number 4. And for time's sake, we usually try to keep things around 4 stories. I think it's been working out very well. The new shorter format, I think, works very, very well. But you know what that means? That means a lot of people's great efforts and papers and research and stories and articles just kind of slip by us every single week because, hey, we can only do so much. Well, you know what that means? That means that we have put in honorable mentions. These honorable mentions are for stories that we just simply don't have time for. They are not worse. They are not less. They are still worth your time. And if you come out to computeramerica.com, you can find the honorable mentions in the show notes with links to, go out and find some for yourself. So, Ralph, let's at least give them the headlines and then, we'll go from there.
Yeah, you're right. This is fun. This comes from interestingengineering.com. Headline, solar panels on train tracks. French railway testing new system for power generation. And when you see the image, you see that they're putting solar panels between the rails of the tracks. And you start to think about this. There's millions of miles of train tracks in this world. What if you put solar panels in between each one of them? And for electrically generated train or trolley type systems, here in Oregon, we have something called the MAX system. They're electric trains. If you had the panels in between the tracks, they could be feeding energy into batteries that in turn could help power these trains. So it's like this perfect circle of climate-friendly energy. So check that story out. I think it's just a clever use. It's not so much that it's new technology. It's just a clever way of using existing solar panel technology by putting it in between train tracks. I think that's really cool.
Very similar to stories that we've done in the past, like trying to turn roads or medians into or even sidewalks into solar panels. So more in that vein for sure.
Yeah, really good one. The next one's from Phys, short for physics.org. Headline, forecasting wildfires. Artificial intelligence-powered tool to combat rising wildfire danger. Now, there's been a lot of work on this. This is not a new thing, but it's a very important topic, especially here out in the West where we had terrible fires. Even in Oregon, we had horrible fires this past summer. And so if we can figure out how to use artificial intelligence to help the teams predict fire behavior and deploy teams and retardants and so forth and so on, based on the help from AI, that would be wonderful. Check that story out. Really encouraging stuff. Next one comes from UNM News, University of New Mexico. That's the source here. University of New Mexico engineers build the future of 3D printing with bendable concrete. So there's been a lot of talk about gigantic 3D printers dispensing concrete to build homes and build structures very quickly. Now they've got this bendable concrete. So interesting. Check that one out. And I believe our last one, here we go. Last one is hydrogen in minutes. The microwave innovation changing clean energy from SciTechDaily.com. You and I have talked so much about hydrogen production. This is another step in the direction of making it more practical and more accessible. So there you go for this week.
No, you have picked, as always, really amazing stories, and I'm really happy that you're able to bring them. Ladies and gentlemen, if you want to find out more, computeramerica.com. Once again, you'll find today's show notes. They'll be up by the time that you hear this, and you can go and check out anything that you like. And Ralph, you picked amazing stories. Thank you to you for bringing them to our attention, and thank you to everyone out there who is doing amazing work to make pretty much every part of our lives a little bit better. As Ralph always says, hey, this was a great way to end the week on a positive note. So, ladies and gentlemen, until next week, I want to thank you so much for tuning in, and hey, we'll catch you here next time. Have a good one. Have a great day. Thank you so much. Bye, everyone.